Okay, this is a related rates question. And we have two sides of a triangle that have lengths 12 and 15. Stop right there. Draw a triangle that represents that. There's nothing said about the triangle. You don't know if it's a right triangle. So just draw a generic triangle, label one side 15, the other side 12. There's a third side, okay? And then if we read on, it talks about the angle between these fixed sides. And so let's call that angle theta. We're told about how theta is changing, the rate increasing, is going up. It's a positive rate, 2 degrees every minute. Then the question goes to talk about the third side. And so that's changing then. If theta is growing, x is growing. So let's label it x. At a particular instant, when the angle between the sides, 15 and 12, the sides of fixed length, is equal to 60 degrees. Okay. When you have an angle, and it's the angle that's in between two sides, and you're interested in the side that's opposite that angle, the way to connect these is law of cosines when there's not a right triangle. Okay, our job, find dx dt. Law of cosine says the following. The side that's opposite the angle fits the following formula. Generally, it's going to be called little c, a small lowercase c. C squared equals a squared plus b squared, the other two sides, squared, minus 2 times the product of a and b times the cosine of that included angle opposite your side. So for us, x is c, a is 15 or 12, and b is the other one, and theta is a variable as well. We're not plugging in the exact values yet. This is our changing picture. From the changing picture comes the relationship between our two variables, x and theta. That's what we need. Those are the two variables. So we plug in and we get that x squared is equal to 15 squared plus 12 squared minus 2 times the product of 12 and 15 times the cosine of the angle between them, the one that's opposite the x. So 15 squared is 225. 12 squared is 144. When we take 225 and add on 144, what we end up getting is 389. If you double 15, you get 30. 30 times 12 is 360. So 369 minus 360 times the cosine of theta. That's what x squared is equal to. We'll leave it like that. It's an equation that relates our variables x and theta to each other. Okay, great. So we got a change in picture. We got our equation that relates the variables. Next up is to look at the instant in time that we're interested in. The key word is when. You see the when that's there. When the angle between the sides is 60 degrees. The 15 is still 15. The 12 is still 12. Can't use degrees. We'll go and put in pi over 3. That's the radian version of 60 degrees. Now the x is a mystery to us. We don't know that. We can use the equation that's right here and plug in to figure out what x is at that instant. We have pi over 3. The cosine of pi over 3 is equal to a half. So we take a half, times it by 360, we get 180. 369 minus the 180 is 189. And we take the square root to give what x is. X is the square root of 189. Not a perfect square, but it has a perfect square that goes into it. 189 is divisible by 9. It goes in there 21 times. So 9 times 21, take the square root of each, and we end up with 3 root 21 is what x is in that instant. So we're all set. The purpose of the snapshot is to plug in constants at the very end of the problem to find the missing value. We're looking for a dx dt. Okay, so far we've done geometry, we've done some algebra. Here comes the one line of calculus. From our equation, x squared equals 369 minus 360 cosine theta. From that equation, our job, is to take the time derivative of it. So x squared's derivative is 2x, but x is changing with time, so we multiply by dx dt. Cosine theta's derivative is negative sine theta, but theta is changing with time, so we multiply by d theta dt. Now the negative that's on in front of the 360 and the negative that comes from the derivative of cosine make the right-hand side derivative positive, 360 sine theta, d theta dt. Okay? So there's 4 different players in this equation. We have 3 of them. We have to find the 4th one. We can plug in now or we can plug in later. I'm going to solve for x here. So I'm going to divide by 2, divide by dx dt. I'm sorry, I'm solving for dx dt. Sorry, solving for dx dt. So I'm going to divide by 2, divide by x. And dx dt is equal to the right-hand side divided by 2x. All right, great. So now let's talk about the particulars. We have the theta is equal to pi over 3. So the sine of theta, okay, we're going to put a pi over 3 in here. What is the sine of pi over 3? It's going to be root 3 over 2. That's what's going to go inside of here. D theta dt. Let's talk about that. So what we have is 2 degrees every minute. But the units are off. We're going to convert that into radians. The multiplier is pi radians. Is exactly equal to 180 degrees. And therefore, we'll have radians a minute per minute. This 2, we turn this 180 into a 90. The degrees will cancel out. So pi over 90 radians per minute. 2 degrees per minute is equal to pi over 90 radians per minute. So that's what's going to go in there. And we already know that x is 3 root 21. So that's what's going to go in the denominator for x. We have everything we need. There's a lot that can happen here. There's a lot of cancellation. Let's deal with the numerator. Put it into one fraction. 360, a pi, a root 3, and then underneath 180. When it comes to the denominator, if you see the root 3 and you see the root 21, there's actually a root 3 inside of that. What you can do is take that root 21 and break it apart and be root 3 times root 7. And later we'll be able to cancel that. In the numerator, there's a little more we can do, right? 180 goes into 360 twice. So it's going to become a 2. So now we're looking at 2 pi root 3, and it's on top of the denominator, which had a 2 already down there, a 3 already down there, and we took the 21, root 21, and broke it apart to be root 3 and root 7. So that's it. You just got to cancel the root 3s, got to cancel the 2s, and we get our final answer for dx dt. The units for it, the x units are meters, like the other sides, and the time unit is minutes. And so pi over 3 root 7 meters per minute is what dx dt is. And if you want, you can rationalize, multiply top and bottom by root 7. And so upon doing that, it's not going to look too much better, but we'll have root pi. Let's write the pi first. Pi root 7 over 21 would be the rationalized version of that. Okay, so when you have a triangle, that's not necessarily a right triangle, and you have the following quantities, 2 sides, the angle between them, and you're interested in the side that's opposite that angle, law of cosines is the way to go. Then and only then. Don't think you should do law of cosines for every triangle question, just in that perfect setup where you have the 3 sides and one of the angles. Okay, great. This is going to be the end of this video. I'll do another video with the last example from this set of slides. Thank you for watching. Like and subscribe, and stay tuned for more. Thank you very much.